speaker, Nikhilesh sir, to continue. Over to you, sir.
Yeah, thank you, sir. Thank you, ma'am. And good morning, each and everyone. Okay, so may I continue, ma'am? Yeah, Dr. Nandita, ma'am?
Yes, sir. Yes, sir. You
Yeah.
can continue.
Yes, sir.
Okay, so before moving further ahead, I just want to know the queries from participants. If anyone has, you all are most welcome. Yeah. Yeah, yesterday I think one of the participants has query, but he was not able to put because of network problem. Right? I think he's not present now.
Yes, sir. Sir is not present now.
I think he was Dr. Pawan.
He will join soon.
Okay, no problem. Yeah, dear participants, if anyone has any doubt, please let me know. If no doubt, then I can start, right? Okay, so I assume that participants do not have doubt. Okay, so let me start. Is this visible? Is my screen visible?
Yes, sir. It is visible.
Okay. So study we have done fixed effect, random effect, pooled method, and so many things we have discussed. Apart from that, we have also discussed endogeneity and exogeneity. Basically, endogeneity should not be there in panel regression. Again, I'm repeating. Endogeneity should not be there in panel regression. Then what should be there? There should be exogeneity. We have understood at last study, at the end of the session, we discussed this thing, that endogeneity. Right? We understood that endogeneity is nothing but a condition in which your IDVs are related to what? Related to error term, right? Which should not be there. And just opposite of that endogeneity, it will be of exogeneity. Like exogeneity, it means IDVs are not related. IDVs are not correlated. Right? The same thing we have discussed yesterday. Whatever you have done, that is a static model. Whatever you have done, that is what? A static model of panel regression. What is the meaning of a static model? Look, I have mentioned here YIT equal to alpha IT plus beta 1, beta IT, or you can say beta 1, or simply beta IT and XIT plus EIT. What is the meaning? This is a static model. Why this is a static model? Because we are saying current year, let's suppose your DV is ROA, right? And IDV is what? Any particular, let's suppose any particular point or any particular variable. Let's suppose a DV is your ROA, IDV is CSR, corporate social responsibility expenditure, right? Now, what we understand that YIT, it means current year. If your data is yearly, what we assume? We assume that current year of ROA depends on current year of CSR. Getting me? What you have understood? We have understood that a static model. A static model means there is no lag. We are not talking about any kind of past, any kind of lag. Getting me? Again, I'm repeating. So a static model means there is no lag. there is no involvement of lag, be it in DV or you can say IDV. Why IT? It means current year of return on assets depends on current year of CSR. But specifically in time series and panel data, it is not possible. It is not possible like that. Majority of the time. I'm not saying always. Sometimes it may also happen. It may also happen that sometimes it may also happen that current year of ROA, right? Current year of ROA depends on ROA IT minus 1. It means in this context, what will be your you can say equation, right? What will be your equation? Can anybody tell me? Yeah, my dear participants, most welcome. Anyone? Okay, again I'm repeating. First and foremost, you have understood fixed effect, random effect. These are nothing but a static panel regression model. A static means like current year, or if your data is year wise, then we say current year of DV depends on current year of IDVs. But in actual, majority of the time, it does not happen. As I mentioned, ROA depends on last year of ROA. So in this case, your equation will be like this. YIT equal to AIT, it means alpha IT plus beta 1 IT ROA IT minus 1 plus beta 2 CSR, or you can say beta 2 IT CSR IT plus EIT. What is the meaning? Meaning is this ROA IT. It means current year of return on assets depends on last year of return on assets and CSR. I hope this is crystal clear, dear participants. If anyone has doubt, please let me know. Yeah.
Sir, could you please repeat this?
Again, I'm repeating, no problem. First, have you understood the concept of this static model? Yeah?
Yes, sir.
Yeah. In a static model, simply we understood that current year of DV depends on current year of IDVs. Simple. In a nutshell, you can understand. But as I mentioned that it does not happen always. Sometimes it happens like this. ROA, it means current year of DV, right? So current year of return on assets. Generally, just see like this. Generally, you say, yes, last year Reliance Industry Limited has done better. Well, so this year also it will do best, isn't it? It means what? It means we are talking about the past. It means you're somewhere this year of data is related to the past data. The same thing happens in this case. It means current year of return on assets depends on last year of return, and then current year of CSR. This is known as your dynamic panel. Dynamic panel. It means what you have understood. You have understood that in dynamic panel, the DV, the lag of DV, is treated as lag of DV is treated as IDV. At least, again I'm repeating, the lag of DV is treated as IDV, and that happens in case of what? In case of dynamic panel. I hope this is crystal clear, ma'am. Yeah.
Yes, sir.
So now we just discuss dynamic panel. It means dynamic panel means what? In dynamic panel, the lag of dv is treated as idv. It means lag of dependent variable will be treated as independent variable, and the same thing we have seen with the help of this. Remember, one of the reasons yesterday I have mentioned, and that is what? Dynamic relationship. If you do not include this dynamic nature, then it will create the endogeneity problem. Endogeneity, try to understand why. Look, try to understand the concept. You see ROAIT, alpha IT plus beta 1 ROAIT minus 1. This is the requirement of your model. Let's assume this is the requirement of your model. But when you are going to make a model, right? But when you are going to, let's suppose when you are going to make a model, now you have ignored it. Right? You have ignored it. And anybody tell me what will be the effect? Yeah, anyone? This is the requirement of your model. But you are going to apply on your paper or might be in your PhD thesis, you are going to apply like this, simple, a static model. The demand is dynamic panel and you are applying simple the fixed random. What will be the impact? Anyone? Yeah.
Sir, the lagged value of ROIT will be included in the error term.
Perfectly fine. Wonderful. Great. It means this ROAIT, you are talking, the requirement is this ROAIT, right? But when you exclude this ROAIT minus 1 from your model, it will be captured in error term. Right? It will be captured in error term, and automatically when it will be captured in error term, it means it might be related to your IDVs, and that will create the problem of endogeneity, autocorrelation, etc. It means, in a nutshell, what you have understood? You have understood that endogeneity is also one of the problems, just ignoring the dynamic relationship. That's why you have understood yesterday measurement error, simultaneity, and this one. Right? So this is all about your dynamic panel and a static model, which you must be able to understand in doing the analysis related to your panel and dynamic panel. Now, but before moving further ahead, there are certain things which I have not discussed yesterday, and let me discuss this and then I'll move to the dynamic panel. There is always a great concern when I deliver the session. There is always a great concern of the participants that, sir, how to deal with stationarity. In time series, we just check the stationarity in panel. Is this necessary? Is this mandatory to check stationarity or like that? Then let's do something, certain assumptions which we have to check in panel. Assumptions of a static panel. Remember, a static panel means what we assume? Anyone? Yeah. Right. There are certain assumptions of a static panel. The first assumption is, generally we see the error term, or you can say the mean of error term. The mean of error term has to be 0. Right? the mean of error term has to be 0. Now I am going to open my Gretel. I request you all to open your Gretel too. Okay, so go to file, click on open data, user file, then I have to convert into XLSX. Then the name of data, Grunfeld. I click OK, then yes, panel, use index variable, then forward, and finally apply. Now, what I mentioned that the first assumption we have to go for this static panel model, it means fixed or random, and that is what the mean of error term has to be 0. How to check? Can anybody tell me that which model was based yesterday based on this data, either random or fixed? Anyone? Yeah,
Fix one.
I think it was random, if I'm not wrong. Let me check. Based on this.
Yesterday it was fixed, random.
Yeah, but let us confirm, because few participants say random, few fixed. So I simply click on this random effect. Okay. And yeah. Yes. Random is suitable model starter, right? So let me apply first random model. And then we have to generate the error term. I think we have already applied this. Let me apply this random model based on this data. Invest is my DV value in capital stock or IDV. Click on random effect and then OK. You get what? You get the result. Outcome of what? Random effect model. And wonderful is what? It has clearly mentioned, be it your fixed or random, you may get that how many cross-sectional units are there. It says 10 cross-sectional units and the time series length is 20. That's why the total number of observations is 200. We have already understood this thing yesterday. Based on this random effect, you have to save the error term first. How to save? Simply go to this save. This is, as I mentioned, that it's a wonderful thing. What it says, it's again I'm repeating. Let me maximize it. This is my random effect model. After getting the result of random effect model, click on save. When you save, there are innumerable options. Out of that, click on residuals. Again, I'm repeating. Click on save. Just click on residuals. And you may write the name also, like I'm writing here, ET. And then I click on OK. When I click on OK, where is this? Where is my error term? Now, automatically in your data file, error term will be saved. Look, earlier up to 5 variables were there. Now another thing or another variable is added, and that is what? Error term. So this is your error term. If you click, you may find this is your error term. Your assumption is what? The mean of error term has to be 0. How to check? Go, just simply select this error term, do right click and click on summary statistics. This is your result. Mean value has to be 0. The mean of, or you can say error term has to be 0. This is your mean. Can anybody tell me either this is 0 or not? Yep. Dear participants, let me know.
This is 0, sir. This is 0, sir.
Yeah, perfectly fine. So this is 0 because exponential is there. So when you find exponential, it means that is 0. The first assumption is done. Anyone has any kind of doubt in first assumption, please let me know, dear participants.
Sir, may I request you
Yeah, no problem.
how you created that random error variable?
Okay, again I'm repeating, don't worry.
Thank you, sir.
First you have to run, let's say I'm just deleting this, right? Your error term has been deleted. Look, first and foremost, you have to apply random effect model. Not always, based on the Hausman test. If you think fixed effect model is better, then you have to apply fixed effect. If you think random effect is better, then you have to apply random effect. In my data, right, the suitable model is random effect. So I apply random effect. Go to model, create on panel, click on panel, and then click on fixed or random. Just I click random effect and invest is my DB, right? And then I click on OK. So this is my what? This is my error term. This is my random effect model outcome. Then after getting the random effect, I can save my error term. How to save? The option is there. Getting me? The option is there, save. So I select this. I click here on save, and then I find innumerable options, right? Out of that, there is residuals. So error term is what? Residuals, isn't it? So I simply save these residuals. The moment I save residuals, I find this option. It says you had 3. So I simply write the name like ET. ET means error term for my understanding, right? And then I click on OK. The moment I click on OK, I get ET in my original data set, specifically in the greater. Right? I hope you have understood. Yeah, dear participant?
Yes, sir. Thanks a lot. Kind of.
Okay, thank you. So after this first assumption, the second assumption is you might have understood or you might have like idea about it. The error term has to be normally distributed, right? The error term has to be normally distributed. How to check this? Look, you all know how the normality can be checked, specifically for the time series on panel. Anyone? Does anyone have idea? I think many of you have idea. Yeah, anyone?
Please repeat the question.
How to check normality in time series or panel data?
Basically, normality like skewness has to be 0, sir. In this,
You are right. Normally, it has to be 0. But how to check? Can anybody tell me the test for checking the normality of time series or panel data?
The Bruce-Pagan test.
Jarque-Bera test.
Jagbera.
You might have heard about it.
Yes,
Jarque-Bera
sir.
test. So it's Jarque-Bera test that helps you to check the normality. So this is my error term. I select it. I go to variable. Right. Again, I'm repeating. I select this variable, which is my error term. I go to variable and I just click on the normality test. When I click on normality test, I get innumerable innumerable normality tests, be it in form of this Dornick Hansen, Sapiro, Lily Force, and the last one is Jarque-Bera test. Our concern is this Jarque-Bera. Our concern is Jarkevara test. What is my null hypothesis for it? Yeah, dear participants?
Normally distributed.
Not normally
Yes.
distributed.
So my null hypothesis is error term is normally distributed. How to interpret this? Can anybody tell me either this is normally distributed or not? Yeah,
Null hypothesis rejected, sir. It's not normally distributed.
wonderful.
P value is significant, less than
P
0.05.
value is significant. It means it is rejected, and we can see that error term is not normally distributed. Now there is a big question. Or majority of the participants, they say, sir, my assumption is violated here. What should I do? Should I report it or not, or should I just go for the you can say again the you can say make the variables normally so that it can be the error term can be also normally distributed. Innumerable queries are there of the participants. Simply, no need to be worried. Either your error term is normally distributed or not, it does not matter. Simply you have to note it down. Simply you have to write it down. It says that even your data is large, right? You have more observations. No need to be normality. Why? Because even your data is large, and if your data is large, if your data or observation is simply, I must write here observations rather than, if your observations are large, no need to be worried about it. Why? Because when observations are large, it converges to the normality as per central limit theorem. Now, what is central limit theorem? Of course, it itself is a time-taking session. So I won't be talking about central limit theorem, right? But try to understand. It can help you to protect. It can help you to protect you from this assumption violation. So no need to be worried about. Might be few participants might be worried about, yes, earlier my data was having this thing. Now onwards, just change your assumptions, just change your mindset towards normality. Even your data is, even your error term, not data, even your error term is not normally distributed. Don't worry for that. As per central limit theorem, it says that it converges to the normality. I hope this is fine, dear participants. Yeah.
Sir,
Yeah.
sir, if the error has a mean 0, then it automatically becomes normally distributed.
But it is not like that. No. It is not like that.
Okay. Okay, sir.
Why I'm saying this thing? Because if you see, the mean value is 0, but it is not normally distributed, isn't it?
Yes, sir.
Yeah. Any query? Any other query, dear participants? Can I move further ahead? If you don't have doubt, then
We can continue, sir. Yes, sir.
wonderful. So we have understood these two assumptions. Third assumption. Third assumption is stationarity. stationarity of the variables, but depending on observations. Right, depending on observation, I have simply clicked it. It means this is not mandatory. This is not mandatory to check. Stationarity is not mandatory to check in case of panel data. Why? First, you all know the meaning of stationarity. Can anybody tell me what is the meaning of stationarity, dear participants? Yeah,
Mean and
Sir.
variance of the series is constant, sir.
wonderful. Mean and variance must be fixed or constant, right? Or you can say it should not vary, right? Now, the question is how to check stationarity of the variables in panel. In time series, there are innumerable tests like you can say ADF test, which is your augmented Dickey Fuller test, then Phillips Perron, right, KPSS, etc. But in panel, one of the very famous test is there. So let's check that. Go to this greater, like my invest variable is there. So I select this invest variable, go to variable, and then I select this unit root test. Again, I'm repeating. Select variable like invest, click on this variable and go to the unit root test. In unit root test, there are innumerable tests. The most suitable test is Levin, Lean and Chew test. Levin, Lean and Chew test is the best test for the stationarity in case of panel. So I select this. Without doing anything, I click on OK and then I get the result. This is the result of the Levin, Lean and Chew test. I hope everyone has been able to run. Yeah, dear participants.
So what will be the null hypothesis in this case, sir?
Yeah, I'm coming to that. First and foremost, let me know, has everyone got the result? Yeah.
Yes.
Okay. The null hypothesis of this is like this is my invest variable, right? So we write invest has presence of unit root or invest is non-stationary. Invest has presence of unit root or invest is non-stationary variable. How to interpret? Look, this is my p-value. This z is score and in bracket you have this p-value, this one 0.9801. Can anybody tell me either null hypothesis is rejected or not rejected? Yeah.
Not rejected, sir. And there is a unit root, and this means series is not stationary.
Yes, it means invest is non-stationary series. Invest is non-stationary series. Why? Because p-value is greater than your 5%. It is clear? Yeah.
Yes, sir.
Yes,
Yes.
sir. Yes.
This is my humble request to participants. Just make the rhythm of two-way communication so that it will be interactive, right? So
Yes,
null
sir, we will
hypothesis is not rejected, and we say that invest is non-stationary series. Similarly, you can check of the another variable also, like very simple. Click on this value, go to variable, and then click on this unit root test. and then select this Levin Lean and Chu test. Without doing anything, just click OK and you find the result. Based on this result, can anyone tell me that either this is a stationary or not?
Yes, sir. This is also not
Non-stationary, sir.
stationary.
Not really.
This is also
Non-stationary.
not stationary.
Yes, this is also not a stationary series.
5% significance crossed.
Yeah, so this is 0.55. It means greater than 5%. So your variable is non-stationary series. So that is also we have covered, we have done. Then the last assumptions which you have to consider here, and that is what? Fifth, that is not fifth, rather fourth. There should be no autocorrelation. There should be no autocorrelation in what? Anyone? In error term, isn't it?
Okay, in error term.
There should be no autocorrelation in error term. It means what?
Yes, sir.
What is the meaning of autocorrelation, dear participants?
Serial correlation with lag, sir.
Sir, preceding variable has relation with the succeeding variable. Connection.
Not variable, sir. Observations in the time series.
Preceding data point has a connection with the succeeding data point.
Yeah,
Yes.
wonderful. It means atom is the same. If you go in detail, atom is same and correlation means degree of relationship, right? It means the same variable, the same error term, right? If the present error term, if ET is correlated with ET minus 1, right? Or maybe the last lag will be any particular order. If today, or you can say this year of error term is correlated with the last year of error term, then that will be the condition of your correlation, right? And that is also known as serial correlation, right? Now, how to check the autocorrelation? Very simple. There are innumerable ways through which you can check the autocorrelation. For that, like, be it fixed effect or random effect, the moment you apply, you get the result of autocorrelation. How? For example, I go to model, click on this panel, fixed or random, invest is my DV, and I select random effect and click on OK. When you get this, you get the result. That is what? Darwin-Watson. Darwin-Watson. Look, how to interpret? Anyone? Dear participants. How to
Sir,
interpret?
with my limited knowledge, this value varies from 0 to 4, and if it is near to 2, then there is no autocorrelation. 0 to 2, then negative, or 2 to 4, then positive.
For that, there are innumerable like literature. You are right, but generally,
Mean should be compared with Durbin-Watson values.
if the value is your 0 to 1, you are right. Whatever you have said, you are right. 0 to 1, and sometimes we say 3 to or 3 onwards. Sometimes we say 1 to 3, right? So 0 to, simply let me write like this. If your value, if Darwin-Watson value ranges in between 1 to 3, it means there is no autocorrelation. Right. In some book, in some literature, you may find 1 to 4 also, but the standard is 1 to 3. If your Darwin-Watson value ranges in between 1 to 3, it means there is no autocorrelation. Why? Less than 1 and greater than 3. If your value, Durbin Watson value is less than 1 and greater than 3 indicates the presence of autocorrelation, or you can say serial correlation, right? Now, based on this benchmark, can anybody tell me either there is autocorrelation or not? Yeah.
There is, sir, because the value is less than 1.
Yes, there is presence of autocorrelation. There is presence of autocorrelation, which is not required, right? It is not required in case of your panel, right? Now, what should you do? If there is autocorrelation, what should you do and why it happens? Again, you ignore the dynamic relationship. When you ignore the dynamic relationship, that may also possibility, or there is also possibility for the autocorrelation problem, right? Why? Because you are talking about autocorrelation. It means there is past relationship. That's why there is past relationship, but you are talking about a static model. So of course, it indicates the presence of your autocorrelation, and which is not desired by your data or desired by your model. Is this fine, dear participants? Yeah. Can I move further ahead?
Yes,
Yes,
sir.
sir.
Sir,
Sir,
Yeah.
sir, Word document, whatever you are creating, you would be sharing that, right, sir? Maybe at the end of your session.
I have saved, no problem, but I think this is a rough idea. So it is not in sequence. Just I'm showing you. If you say, I'll be sharing you. No problem.
Yeah, it will give some concrete.
No problem. I'll be sharing. I'll be sharing. Don't worry. I'll be sharing. But this is not in a sequence. So don't think it is in sequence. I hope you can understand. Even it is
I
not.
understand. We understand, whatever topics we have covered, it is there, so that we can recollect.
Wonderful. No.
Organizer shall share the video. So
Video
everything
will be
will
there, but the document, whatever topics we have covered, it would be easy for us to recollect.
Yeah, I'll be sharing to Dr. Anandita ma'am, and she will forward you all, right?
Right, sir. Thank you very much.
Now,
sir,
yeah.
sir, of the 4 assumptions, you said normality we will ignore because of the central limit theorem.
Yes.
And stationarity, sir, what to do? If it is there, shall we do the first differencing and make it stationary? If it is not
Okay.
stationary?
I'm coming to this point.
Okay.
First, I hope everything is crystal clear, right? Is this clear till now?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, I have discussed that the variable has to be stationary. Most of the cases, when you go through, specifically in Indian context, I'm talking about, not only Indian context, even if from the foreign point of view also, even foreign authors also do like this. There is a very famous book for econometrics for panel data, and that is by Baltage. When you go to Baltage, I do not recall the exact page number, but might be, I think, 428 or 426 page number. It has been clearly mentioned. It may differ from the edition to edition also. So it has been clearly mentioned. Stationarity, checking the stationarity of the variable is not required. Why? If your time period is more than 25 years of data, more than 25 years, then you have to take the stationarity. Some people say the large number of time period. The same thing is there, which has been mentioned in Baltaki book. Now the question is, in majority of the context, People do not take the 25 years of data. Hardly people go for the 10 years, 5 years. Hardly some people go for the 10, 15 or 20 years because data is not developed. The data is not as stronger in case of our Indian, you can say, research point of view. Right? So, no need to check the stationarity. If your data is, if your time period in your data is more than of 25 years, check the stationarity. Otherwise, do not check. Now the question, first, have you understood? Yeah, the participant who has asked this question.
Yes, sir.
Now the
Yes.
question is, sir, I have the data of 25 years, right? Or maybe more than 25 years. What should I do? Should I check the stationarity? Yes, you have to check the stationarity because reviewer may ask you, may pinpoint why you have not checked the stationarity. Now you might be knowing each and every test is the game of stationarity. In time series, you might have heard about co-integration, ARDL, vacuum. These all are the game of stationarity. The same thing happens in case of panel also. Now, let's suppose you have three variables: invest, value, and capital stock. If all three, you let's suppose you have the data of 25 years or more than 25 years. If these all variables are IO, IO means anyone?
Integrated of order zeros, level data.
Integrated at level.
Yeah.
It means stationary at level.
Level data.
Stationarity at level. If all are IO, you have the data of more than 25 years, and trust me, majority of the time when you have the data of more than 25 years, of course, there might be the huge possibility to be IO. If all your variables are IO, then you can go for the static model, a static panel model. Right, a static panel. Sorry. Just a second. But if all right now, what we are doing without doing anything, we go for the fixed random, isn't it? We have the data, we just go for the pooled fixed random. But when you just go to check the stationarity, then your test will be purely changed. Why? Now let's suppose there is a mixture of the variables are mixed of what? IO and I1. Which test we have to apply? Anyone? Can I know?
The dynamic.
If variables are mixed of IO in I1, then you have to check the ARDL panel. There is also the category autoregressive dynamic, right? Autoregressive distributed lag model, ARDL panel, if variables are IO and I1. If variables are, all variables are I1, then you have to apply what? Anyone? Which
Sir,
test?
VAR.
Co-integration, sir.
Yes, co-integrated panel. It means the moment you check the stationarity, the data, or you can say, rather than saying data, your test will be different. And these are the various form of your test. That's why in majority, in few paper, you may also find an application of ARDL panel, an application of co-integrated panel. Why? Because they might have the data point larger in terms of period, like more than 25 years. In few study, people apply even 20 years also, even 15 years also. There are innumerable literature, but I personally, I prefer, because I follow Baltagi book and it has been clearly mentioned. So in case of 25 years above data, only go to this such type of stationarity. Otherwise, no need to check the stationarity in your data, in your variable. I hope this is crystal clear. Yeah, dear participants. Am I audible? Dear participants, am I audible?
Yes, sir.
Yes, sir. Yeah.
The participant who has asked, I hope this is clear to her. Yeah.
Yes, sir. Yes, sir. It is clear, sir.
So these are all about your static panel in terms of fixed, random, or pulled. Now let's move to the one thing. I think the test which I am going to mention, this is not available in eViews, so be careful, and this will be very helpful. Sometimes people work on short panel. Let's suppose BRICS. Let's suppose BRICS. It means only five countries are there, right? Brazil, Russia, India, China, and South Africa. 5 countries are there, right? You have IDVs. Try to understand the conditions. You have IDVs 6, BV1. Time period may be any particular thing, like let's say 10 years, 15 years, it does not matter. But why I'm saying this thing, I just want to say BRICS is, the cross-section units are 5. Sometimes people do that, even people do for their PhD purpose also, right? Now, if you apply random effect model, fixed effect, you will be getting the result. But when you are going to apply random effect model, it does not give you the result. It does not give you the result. Why? What you have understood here? It means if IDVs are greater than cross-sectional units, the point is what? The crux is what? If IDVs are greater than N. N is what? Cross-sectional units. Let me write this. Units. It means N. Look, when you are going to apply a random effect model, like I go to this model, click panel, fixed, and invest is my dependent variable, and I click on random. The moment I click on random, earlier it is disabled, right? The moment I click on random, it is enabled. And if I select here, there are innumerable options. It says random effect by Swami and Aurora, Swami, Aurora, oblique, Baltagi Chang, and then the third one is Narlov. So by default, we apply Swami and Aurora model. This just for your kind information, this facility is not available in eViews. So when you have more than if your IDVs are more than your cross-sectional units, then Swami and Aurora model does not work. By default, it is Swami and Aurora. You have to change the model. The same thing I'm going to write. If IDVs are greater than cross-sectional units, random effect model, which is what? Swami and Aurora, right, does not work. Right. So which model will work? In this case, Narlov model will work. Narlov. So here, where is it? Yes. It means here you have to select this Narlov, and then you have to do OK. It means It means you may find using Narlov's transformation. So what we have understood? We have understood that in case of your IDV is greater than the number of cross-sectional units, Narlov model has to be applied. Narlov model has to be applied. I hope this is fine. Yeah, dear participants, any doubt?
Sir,
Yeah.
sir, actually, I was facing the same problem in e-views. The notification was coming that the number of cross-sectional units is great. Same problem was coming. So, sir, in e-views, Swami and Aurora will not work. So I went to options and there were two other options, one Wallace or something, and one more. So when I clicked the others, it worked.
Yes, so that's why I'm saying. It means directly you can't get this. So it's good. If you have been able to identify, it will be better, right? The same thing happens in this. You can say Gretel also, right? Can I move further ahead? Yeah, dear participants.
Yes, sir.
Wonderful.
Yes, sir.
So now what next? The next is dynamic panel. Just recall, think, pause your mind. Let's take 1 or 2 minutes, pause your mind. Innumerable things you have read, you have understood till now. The next is a dynamic panel. So I have written somewhere the equation. Let me search. Where is it? I don't know where I have written. I think it was deleted. Okay, no problem. So I have simply said that in dynamic, what happens? The lag of dv is what? Considered as the idv, right? The same thing we have discussed. The lag of dv is, yes, this one. So we have understood that the lag of dv, like ROAIT, is dependent on its own lag. Then it will be your dynamic nature. So let's discuss this dynamic panel. Okay. So in case of dynamic panel, let's see this PPT. Look, in dynamic panel model, the lag of dependent variable is used as explanatory variable. It means independent variable. Yit equal to alpha I plus beta yit minus 1. Then this lambda xit, ui, it means mu I, eit. Let's see. Yit is dependent variable measured for form I at time. This alpha is intercept, beta is slope coefficient. This slope coefficient is also known as short run effect, right? Short run effect of yit minus 1. Then this lambda is slope coefficient of xit. It means this is nothing but simply coefficient. Either you say beta or you say lambda. And then remember this mu I is nothing but individual specific effect. Try to understand. Yesterday in PPT I have mentioned this alpha I. So either you say alpha I or you say mu I, it is nothing but unobserved heterogeneity, individual specific effect, right? Because this is panel. So even be it your panel or dynamic panel, you'll be having this what? Individual effect, right? Now, what suggests dynamic panel? Directly, you cannot jump on the dynamic panel. Directly, you cannot jump on the dynamic panel. The moment you get dynamic data, don't think that you have to apply dynamic panel, because there are certain guidelines for that. There are certain criteria for it. And what are these? These are two major components. The first one is underlying theory. You have gone through literature review. You find the proper theory, proper justification. Then you have to apply dynamic panel. One reason, like for example, dividend decisions are normally dynamic in nature, as previous year dividend decision may affect this year decision along with other explanatory variables, right? So in this case, what happens? You may go for the dynamic panel. Then second one is existing empirical literature. Of course, you see the literature and the similar, like your study, you may find XYZ has used this study. Then of course you can also go to the same study. But if these two things are not there, then you do not have to apply dynamic panel. Otherwise, justification will be not possible for you, right? So how to go for dynamic? Let's understand this thing in a detailed way. Look, let's see the equation. Assume that our true model is dynamic panel. Then the requirement will be like this, right? Requirement will be like this, like yit equal to alpha plus beta yit minus 1 and this. But we estimate the following static model, which I have already discussed. There is requirement of dynamic panel and you apply what? Fixed effect. Then what will be the consequences? The consequences will be like this. Error term may have the serial correlation and endogeneity problem. The same thing I have already discussed. Isn't it? The same thing I have already discussed. It means the problem will remain there and the problem will be related to in form of serial correlation or endogeneity. There will be a problem with the error term. Of course, because it will be captured in error term, as one of the participants has also mentioned this thing. Now, let's consider it. When we estimate the above equation, considering the fixed effect estimator, then the explanatory variables would be correlated with error term, which violates the assumption of a strict exogeneity of fixed effect estimator. Remember, if there is requirement of dynamic panel and you do not include it, it means it will be captured by error term, and because of that, endogeneity problem will be there. And we have already understood that endogeneity should not be there in fixed effect estimator. Endogeneity should not be there in fixed effect estimator. Why? Because it is the requirement of exogeneity, just opposite of endogeneity. And it results into biased estimators. And such a bias is called Nikel's bias. Nikel's bias. Try to understand. Such bias is called Nikel's bias. So Nikel's bias means what? If someone will ask you, what do you mean by nickel bias in dynamic panel, your answer has to be, this is nothing but endogeneity problem. Because of the endogeneity, there will be the biased estimators. Estimators will be biased, and that is known as Nickel's bias. Have you understood this concept? Yeah, dear participants. Let me know from you all. Have you understood this concept or not?
Yes, sir. So theoretically, a dynamic panel shouldn't be estimated with fixed effect models. If we do that, then the estimators will become biased, and that bias is called as Nichols bias.
Yes. So that is what? That is your Nickel's bias. Now the question is,
Sir, sorry to
Yeah,
interrupt. Sir,
no problem.
dynamic panel can only apply in the long run, or can we apply in the short run as well?
No, not necessary. Earlier, it was believed that we used to go for the long, but it is not necessary.
Okay, sir.
Because literature is the main criteria, literature and the justification. Even it can be applied in short panels, right?
Okay. Yes. Thank you, sir.
Look, now let me talk about this. What is the lesson? The lesson is, if the true model is dynamic panel model, then we should not ignore the dynamic structure of the model. If you apply pooled OLS to a dynamic panel model, then the coefficient of lag of DV variable will have upward bias. But if you apply fixed effect model to a dynamic model, then coefficient of lag of dependent variable will be downward biased. What is the meaning of this slide? Let me talk about this. What it says that, let's suppose there is a requirement of dynamic panel, and you are going to apply pooled OLS. Right? You are going to apply pooled OLS. It means simply the pooled regression. What happens? In this case, your estimator will be upward bias. It means, let's say, this is the equation. ROA-IT, alpha IT plus beta 1 IT, ROA-IT minus 1. This is the requirement, but you have applied this one. So here, this beta 1, this will be biased. This will be upward. Upward means, let's suppose the true coefficient will be, let's suppose, beta I1 IT is 0.5, then it will be upward. It means it will be more than the required coefficient. Again, I'm repeating, upward. It means what? It will be more than, it will be your coefficient will be more than the required. Upward biased, right? If you apply pooled OLS on the dynamic nature of data. But when you apply fixed on this, then it will be downward bias. Downward bias means what? It will be, your beta IT will be less than as per the required. It will be more than, even it will be more than it, like let's suppose 0.40. It means what? Downward bias. Downward bias. So this downward bias means what? It is less than the required, you can say, coefficient. The same thing has been mentioned here. If you apply pooled OLS to a dynamic panel model, then the coefficients of lagged of dependent variable will have the upward bias. And if you apply fixed effect model to a dynamic panel, then the coefficient of lagged of dependent variable will have the downward bias. Hence, if the requirement of dynamic panel, then you have to apply dynamic panel. This is the summary. This is the crux. Now, let's revise this concept. This concept is done, like YIT alpha B this one. At model, this YIT minus this, YIT this. Then what is the solution? If there is problem, right? One of the way is like you have to do differencing. You have to do, let's see this. Let's see this. I'm coming to the differencing. Let's see this equation. Yit minus yit minus 1, then beta yit minus 1, yit minus 2 plus lambda xit minus xit minus 1 and error term it minus error term it minus 1. Since the error term is correlated with one of the regressors, there will be a problem of endogeneity. Hence, the estimator will be inconsistent. Now, the question is, there are two problems. What are these two problems? Problem of endogeneity and cross-sectional effects. In this model, ROAIT, this ROAIT plus beta CSRIT plus, I'm writing here, alpha I, right? Because alpha I will be also there because of individual effect, because of the differences. So what is the solution? What is the solution? Solution, let's see, is by differencing. Differencing the model. It means, can anybody tell me what is the meaning of differencing? Yeah? Anyone?
Differencing is like taking the difference of the data points.
If I say first differencing.
First differencing means we take the difference from the current data set, means current period to the last period data.
Perfect.
Difference between T and T minus 1.
Perfect. It means YIT minus YT minus 1. Simply, if I say first differencing means what? YIT minus YIT minus 1. Isn't it? This is the first differencing. Here, let me talk about first differencing. So what you write? ROAIT minus ROAIT minus 1. Isn't it? Then equal to alpha IT minus alpha IT minus 1, isn't it? Then plus beta 1 IT ROA IT minus ROAIT. This is ROAIT minus 1. ROAIT IT minus 2 plus this beta 2 IT CSR IT minus beta 2 IT CSR IT minus 1 plus error term IT EIT minus EIT minus 1. Have you understood this differencing which I have written? Very simple. I simply did current year of data minus, or simply current year of DV minus last year of DV. Current year of IDV minus last year of IDV. Very simple. I hope this is clear, dear participants. Yeah?
Yes, sir.
Is it clear or not?
Yes, sir. Sir, in this equation, second term, ROAIT minus 1 minus ROAIT minus 2. Because one value has no one data point has no value, right, sir, here, because we have calculated the returns. Is it so, sir?
Pardon, can you repeat it again?
In this equation, second term, sir, like ROA IT minus 1, we are taking the difference of second T minus 2 and T minus 1.
Yes.
And rest of the things are T minus 1 and 2.
Yes, because here there is ROAIT minus 1. It is already there. So if you differentiate, then you have to take from 2, na?
Okay.
Isn't it?
Right.
The same thing happens here. It means what? Why you are going to difference? Why you are going to do the first try to understand. With the help of any software, you can easily get the value. But the basic thing is this. If you do not understand this, it means there is no relevance of understanding the dynamic panel. Try to understand. If anyone has problem, please let me know so that I can revise it also. Dear participants, have you understood this equation? Yeah?
Yes, sir.
Okay. So everyone has understood. Now, ROAIT minus 1. What is the meaning of this? This is nothing but your T. It means difference of ROAIT. It means current year minus last year. So that is nothing but difference of ROAIT. We can write also like this, isn't it? Then alpha AIT and alpha AIT. I must write here, sorry. This alpha is constant, so of course it can't be like this. Alpha AIT, alpha IT and alpha IT. So it will be 0. It means alpha is constant is removed, isn't it? Then beta 1 ROAIT minus 1 ROAIT. So simply we say difference of what? Beta 1 ROAIT minus 1 plus. This is the treatment of this. Then this alpha I. Look, in this equation, alpha I is also there, but alpha I does not have its lag. This is constant. Unobserved heterogeneity. Unobserved heterogeneity can be in any particular thing. So this alpha I and alpha I will be also missed out. So it will be nil. Now, difference of this beta CSR IT, it means difference of CSR, or simply we write difference of beta 2 CSR IT, and then plus difference of the error term, right? If anyone has problem, let me know, dear participants. Yeah, have you understood or not? So what you have understood here, by differentiating what you have determined, what you have computed. Anyway, your response, please.
Individual effects got cancelled, sir.
Yes, you are right. Two things you have noticed here. One thing is your constant is removed. It means intercept is removed. Another thing is individual effect is also removed. It's good thing. It's a good thing because remember, recall, since yesterday I have been talking, the purpose of be it a static model or dynamic model is what? To remove the unobserved heterogeneity, to control the unobserved heterogeneity. In fixed effect, remember what you have understood. Can anybody tell me? Anyone? In fixed effect model, what you have studied yesterday? How to control unobserved heterogeneity. Can anybody tell me?
Sir, through error component. One is for individual effect. Another is for the whole effect. Sir, I don't know, sir. Is it correct?
Yesterday we have done in fixed effect that unobserved heterogeneity is controlled by giving the intercept value over the cross-sectional units
Cross-section units.
irrespective
Yes,
of
sir.
time. Isn't it? So we have
Yes.
controlled the unobserved heterogeneity. The same thing happens here. By differentiating, we have controlled this unobserved heterogeneity. So two things happened. One is constant is removed, and another one is unobserved heterogeneity problem. They are removed, but still there is a problem. Even by differentiating, still there is a problem. Can anybody guess what is the problem? Anyone? Yes. Still there is a problem of endogeneity. How? Because this is the last year. Remember, differentiating of what? Last year. This is not the current year. Try to understand. Differentiating of the last year. That's why you have written here ROAIT minus 1, ROAIT minus 2. Right. So differentiating is what? Differentiating of ROAIT minus 1. So still, this is not the current differentiating. This is the last year differentiating. Hence, this effect can be captured in the error term. And because of that dynamic nature, there is a problem of endogeneity. What is the crux? The crux is by differentiating, by doing differentiating, we have controlled the unobserved heterogeneity. Unobserved but not the what? Endogeneity. By doing differentiating, we have controlled the unobserved heterogeneity, but not the endogeneity. Have you understood this concept or not? Please let me know, dear participants. Yeah?
Sir.
Look, even yesterday, I have already mentioned that we have entered into advanced panel. So I hope you all are getting. Should I repeat it again, dear participants? Until or unless I know, how can I explain again and again, dear participants, please? Is this clear? Should I
Yes,
move
sir.
further ahead?
Yes,
So
sir.
please
Yes, sir.
repeat it once more.
What I said that by doing differentiating, by doing the first differentiating, we can solve the problem of what?
Heterogeneity.
Observed heterogeneity. Why? Because this alpha I and this alpha I has gone. It is not found. It has been just removed by differentiating. The true equation is this. But the problem is here, this is differentiating of what? This is the differentiating of ROAIT minus 1. It is differentiating of YT minus 1. This is not the actual. This is not the current differentiating. This is the last year differentiating. In this case, what happens? Its effect will be captured in this error term. Hence, still there will be the problem of endogeneity. Generally, we go for the dynamic panel. For what? The purpose is to remove the unobserved heterogeneity and endogeneity. Right? But here, with the help of this model, we talk about and we understood that we can control unobserved heterogeneity, but not the endogeneity. So, what is the solution? How to control the endogeneity problem? Then we say that to remove the endogeneity problem, we apply or we include instrumental variable we include instrumental variable. Till now, what you have understood? Till now, we had understood the concept of dependent variable, independent variable. Now another variable has been added, instrumental variable. So with the introduction of instrumental variable in dynamic panel, we can remove the problem of androgeneity. Again, I'm repeating, by differentiating, you can remove the problem of unobserved heterogeneity. We can remove the problem of individual effect, but by application of instrumental variable, we can remove the problem of androgeneity also. Is this crystal clear or not, dear participants? Yeah.
Yes, sir.
So, what is meant by instrumental variable? Let me talk about the concept of instrumental variable. Till now, just pause 1 to 2 minutes and think what we have discussed. Just think. Only 2 minutes. 1 or 2 minutes. Just think. Yeah, dear participants. So you have realized this thing that unobserved heterogeneity can be solved out with the help of differencing, but endogeneity problem can be solved with the help of instrumental variable. So what is the meaning of instrumental variable? Let's talk about this. I have already mentioned, so still there will be problem, how to solve out, what is the way out? The way out is instrumental variable. It means use the instrumental variables. Now, instrumental variable. If I talk about instrumental variable, we say that if in order to take care of endogeneity problem and inconsistent estimator, we can use instrumental variable. Let's see a variable j. So earlier we had the concept x and y. X is idb, y is db. But another variable will be added here, and that is what? J. So a variable j is an instrumental variable if j is not correlated with the error term and j is correlated with the regression. Try to understand. first I'll be coming to this point, but let me talk about the in a very simple way how to explain the instrumental variable. Look, in current juncture, earlier it was not the concept, but right now, even nursery school or any other schools, what they prefer that if the parents of kids are educated, only the kids can be admitted in that concerned school. It may be also like that, which is found and which has been a kind of tradition for the education sector in current juncture. However, can you brief that the performance of kids, just think, can you say that performance of kids or might be the marks obtained by kids may be also affected by parents' education? Yeah. Anyone? Dear participants? Can you say? Am I audible?
Not completely, but
I could not follow, sir.
Marks of kids, that is DV. So IDVs might be the number of working hours, but the number of reading hours, isn't it? Of students, of kid. Number one might be concentration, might be tuition, right? These are the what? These are the, you can say, DV and ITV. But can you say that marks of kids will be also affected by parents' education? Yes, it might be.
to some extent.
It might be. It means directly these parents' educations are not affecting, but indirectly it may affect. Another example. Let's say there is a candidate, Mr. Ram. Mr. Ram is a very bona fide student, wonderful bona fide student. He has secured good marks in +2 or maybe graduations or post-graduation. When you go to job, Mr. Ram has been asked that your schooling has been done from where? Either from government school or private school or convent school. Of course, during the interview, can you say that the performance of Mr. Ram may be affected by schooling? Of course, it might be, because the way of speaking from convent school might be different from the way of speaking to the you can say government school, isn't it? It means such type of variables are known as instrumental variable. Like here, parents' education. You know, yeah. Let me complete, Dr. Salu, and then I'll come to you. Just let me complete. Hardly it will take 1 to 2 minutes. It means such type of variable which is not affecting DV directly. Such type of variable is your instrumental variable. For example, kids. Of course, marks of kids will be dependent on the kids reading hours, consultations, if he study tuition and etc. But it is not necessary that parents' educations can also affect. But yes, if it is affecting, then that is known as instrumental variable, and it is happening because let's suppose it is found. Let's suppose parents are not educated. What the kids are doing, parents do not know, but at least the parents who are educated, they know, yes, how much homework you have done. If not, how to do. They also solve the problem and do something like that. It means indirectly these variables affect the performance of kids. That variable is known as what? Instrumental variable. Yeah, Dr. Salu, I think you were asking something.
Yes, sir. Sir, as you said, some variables will not be affecting the study, not directly but indirectly. So I have a concern, as I'm basically from the finance. So we do a study on the company's profitability, their capital structure. In some of the papers in the literature, I have found that the scholars take few variables as a control variable. For example, if I'm studying infrastructure companies, then the age of the company, some people take as a control variable. But can I take the same variable as an instrumental one? Because I know it can affect a company's performance. So one variable taken as a control variable in the previous studies, can I take on those variables if my logics are correct to be instrumental variable?
No. My simple answer is no. Control variable cannot be instrumental variable. Number one. Number two, actually in current juncture, few studies you may find these are the control variable, and few study you may find these are the instrumental variable. So that may be different thing. Getting me? Let's suppose you talk about size or revenue, isn't it? Size or revenue. Generally, in finance domain or economics domain, we use like this, isn't it? So these are control variables. Now the question is, sir, can it be control variable? 99.99% when you find these are not used as you can say instrumental variable, because generally instrumental variables are the lag of variable itself. I'll be talking about this, don't worry for that. How to the problem is how to define or which variable I have to consider instrumental variable. I'll come to this point, don't worry for that. But you have asked a query, that's why I'm answering, that's why I'm replying. You are not supposed to consider the control variable as the instrumental variable, right?
Okay, sir.
Yeah, why I'm saying this thing, because you have defined in my study these are the control variable, and you are considering these control variables also as instrumental variable, then that is not good. But yeah, however, if you like, you may find some of studies have used instrumental variable this size, then you can quote here this variable has been considered as the instrumental variable. Then you do not have to apply what? You do not have to apply it as the control variable. You have to go with the instrumental variable itself, right? So there is difference between there is difference between control variable and you can say instrumental variable. And what is difference? I'll show you while running the dynamic panel. Then automatically you will be getting, yes, this is the difference between control variable and instrumental variable. It is fine, ma'am?
Yeah. So, sir, in every situation, our categorization of the variables need to be supported by the literature only.
Of course, majority of the time, because how to justify? Justification you have seen in dynamic, there are two things. One is existing study, and another thing is your you can say underlying theory. The reason are there, that's why we have to go or we have to support with our literature, right?
Okay, sir. All right. Thank you,
Yeah.
sir.
Now, so indirectly we have understood, indirectly they are affecting your DV. But what should be the nature of that J? What should be the nature of this instrumental variable? This is the nature of instrumental variable. It says that a variable J is instrumental variable if J is not correlated with the error term. It means it should not be considered with the residuals, and J has to be correlated with the regressors. It means J has to be correlated with the independent variables. For example, what is the condition? Condition is parents educations. If I use this as you can say instrumental variable, so this parents education has to be related with what? Number of hours of kid, right? It has to be considered as number of hours of kids. Then parents education has to, it means there should be correlation with your instrumental variable and you can say the independent variables, but it should not be correlated with error term. This is the criteria, this is the way through which we can or which we have understood. Now, so we have understood this dynamic panel. It means in dynamic panel model does not do anything but simply it apply what? Simply applies instrumental variable. If someone will ask you what dynamic panel does, then your answer has to be like this. It simply use the instrumental variable to remove the endogeneity. Very simple. What are the methods? What are the methods of estimation of dynamic panel estimation? What are the methods? Method is number one, Anderson and Xiao model. Number two, your difference GMM. And then we talk about system GMM. This difference GMM is also known as Erlano and Bond model. I'll be talking about it. What is meant by it? One by one, I'll be talking about this. So one is Anderson and Xiao model, then the difference GMM model and system GMM. In current juncture, even as per literature also, we only talk about these two models, difference GMM and system GMM. We do not talk about Anderson and Xiao model. So difference GMM and system GMM. Let's talk about difference GMM and system GMM. Okay.
Sir, if you don't mind, give a 5 minutes break, sir, then we will start. 5 minutes break or 3 minutes break.
Okay. Dear organizer, Dr. Ananda,
We
are
will
there?
be closing the session at 12, just 15 minutes. So we can, I think, have a break after 15 minutes. Sir.
Okay, fine.
Okay, no problem. But you can take 2 minutes. No problem. I can pause 2 minutes. No problem.
Right, sir.
Okay, sir.
Okay. 2 minutes.
Sir, can I ask a question, sir?
Most welcome. Yeah, you may.
Sir, for identifying instrumental variable, like, is there any test like this variable can be considered as instrumental?
No, there is no specific test for that.
Okay. So we have to purely look at the variable and understand.
Yes, you have to, and this is not like that you directly run and get the result. There is try and error method. Getting me? You
Yes,
apply
sir.
keeping as this, then you'll be getting something different result. Then you have to check. You have to do trial and error, and of course you will be getting this. Don't worry for that, right?
Yes, sir. Yes. Sir, and even for dynamic panel, like you have given two, one is literature and one is in case of dividend theory. But apart from that also, sir, many studies are there which are like concentrating on dynamic panel. So exactly how do we understand whether to go for dynamic? Like
Look,
Sir, thank you, sir.
the basic, simple, the answer is your two things, literature and this. Why? If literatures are not supported and your underlying theory is not supported, the basic question is why have you applied this? Because you can go for the simply you can say static panel also. Few participants or few scholars, what they do, they apply fixed, random, and then they report the dynamic also. In few paper you may get. Why?
Yes.
Because they show that there is endogeneity while applying this fixed and random. Getting me? While applying fixed and random, they find endogeneity and autocorrelation problem. That's why they have gone to this. The same thing happens with the case of your existing also. If let's suppose you are willing, just my piece of advice, you are willing to apply dynamic panel, right? You do not find these two things. Then what you can do, you can apply this fixed and random, and then you may find the violation of assumptions like autocorrelation, and then the you can say autocorrelation problem, and then another one is what? Endogeneity. Then you have to go for the and simultaneously fixed, random, and you can report the dynamic also. Getting me?
Okay. Yes, sir.
Yeah.
Yes, sir.
So
Thank
people
you.
do that. People do like this. You are right. But again, the robust result will come with the help of these two conditions, which we have already discussed. Right?
Okay, sir. Thank you, sir.
Okay. Now,
Sir, can I
yeah,
ask a question?
most welcome.
Sir, you have told that instrumental variable is related with the IDV. Right, sir?
Yeah.
Sir, if I regress, means make a regressions with IDV as with the instrumental variable, is there any problem of multicollinearity or something else?
Look, I say related, but I do not. I have not said highly related. Try to understand. Multicollinearity is the problem of high correlation. Getting me?
Yes, sir.
Yeah. So the two words make the huge differences. When I say related and we say highly related, multicollinearity may happen because of the highly related or highly correlation, right? High degree of correlation.
Okay,
Is
sir.
this fine?
Yes, sir. Thank you, sir.
Okay. So let me talk about this. I think we can proceed further ahead. Yeah. So the method is GMM, generalized method of moment, which is known as difference GMM, and another method is system GMM. Let me talk about this GMM. What is meant by GMM? Try to understand the concept. Assume that regressors X are correlated with the error term. Then it will create the problem of endogeneity and inconsistent estimates, which we have already understood. In such a case, we may use instrumental variables J such that this correlation is zero. This provides unconditional population moment condition. So when J is not related to error term, it means this error term is not correlated. The estimation of NE, it means JE means zero. It means the correlation is nil. Correlation is zero. This provides unconditional population moment conditions. Estimators are satisfying these conditions are called generalized method of moment estimators. Again, I'm repeating. What is the meaning of GMM? People say, actually, though they discuss different GMM, system GMM, but apart from that, we have to be able to understand the concept of this, what is meant by this GMM. So generalized method of moment, it simply means that when the J and error term is not correlated, it means it provides the unconditional population moment condition. Unconditional population moment conditions, and satisfying these estimators That condition is your GMM. Now the question is, what is the meaning of moment condition? Getting me? What is the meaning of moment condition? So it is mentioned here. Moment conditions are expected values that specify the model parameters. In terms of the true moments, the sample moment conditions are the sample equivalents to the moment conditions. So moment conditions are what? Expected value. It means forecasted value, estimated value that specify the model parameters in terms of the true moment. Remember, you might have heard about in a statistic moment condition, isn't it? Like you can say mu1, mu2, or so many moment conditions you might have studied, right? So in one sentence, what we can say that number one, when your instrumental variable is not correlated with error term, that provides the unconditional population moment. Now the question is, what do you mean by moment condition? Moment conditions are the simply estimated value, expected value that specify the model parameters in terms of true moments, right? And GMM finds the parameter values that are the closest to satisfying the sample moment conditions. So this is your GMM and the concept of moment condition. Now,
Sorry,
yeah,
sorry, sir. It's not quite clear to me. Can you just simplify it, maybe with the help of example?
first try to understand this. J or error term, ET, equal to 0. What is the meaning? Meaning is error term is not correlated. It means simply meaning is instrumental variable is not correlated with the error term. It simply means instrumental variable if instrumental variable is not correlated with error term, what will be the consequence? It provides the unconditional population moment. Unconditional population moment condition. I do not have to explain this thing because we all know what is the meaning of population, right? So it is the unconditional population moment. Now the question is, what is meant by moment condition? So I simply mention here moment is nothing but expected value. Expected value of the true parameter. Simple. Parameter, you all know, parameter means what? Alpha and beta. So moment is nothing but simply the moment condition is nothing but the expected value that makes the true parameters. So the same thing happens here. It means it specifies the model parameter in terms of true moment. So true parameter can be created with the help of this. Am I right? Yeah, dear participants, have you understood?
Yes, sir. Yes, sir.
So this is the understanding of generalized method of moment. And sorry, this is the meaning of your simply GMM or generalized method of moment. Now,
Sir, sorry to
yeah,
interrupt. Sir, you wrote movement is not expected value of the true parameter.
yeah.
Yeah.
So moment is expected value of the simply true parameter, right?
Right, sir.
Now, how to apply this difference generalized method of moment? Let me talk first. Let me talk about this difference generalized method of moment. So this is the meaning of your this Erolano and bond estimators. So either you say difference GMM, or you say Erolano and bone model, both are the same. Either you say generalized method moment, or you say Erolano and bond estimator, both are the same. The Erolano and bond estimators are known as difference GMM estimator. They are called difference GMM estimators as they use instrumental variables for the first difference equation, which takes care of the individual specific effects. That is to say, instrumental variables are defined the difference variable. But this instrumental variable defined at level. Try to understand. As I mentioned, either you say, some people say Erolano and bond model, some people say difference GMM. Both are the same. First, try to understand. In dynamic panel, if people say ki I have applied Erolano and bond model, it means what? Simply he or she has applied difference GMM. Now, what it says, what Erolano and Bond says, it says that they are called difference GMM estimators as they use instrumental variables for the first difference equation. At the back end, when I apply this Erolano and Bond model, I'll talk about this. At the back end, what it does, it applies on the first difference equation. Why? Why first difference? I have already told you, because when first difference is done, individual specific effect is taken care. It means it is removed. So individuality, cross-sectional effects, or you can say unobserved heterogeneity, all are the simultaneous things, or sorry, all are the synonyms. So these error terms, or sorry, these individual effects can be omitted, can be removed. That is the purpose of applying this difference. That is to say, the instrumental variables are defined for the difference variables. Right. I hope this is fine, dear participants. Yeah?
Yes, sir.
So this is your Erolano and Bond estimators. Now, how to apply this Erolano and Bond estimator? It means how to apply difference GMM we can do after the break. But still we have 3 minutes for break. I think still we have 3 minutes to go for the break. If you have any query, you are most welcome. Just put it out so that we can start this Erolano and Bond estimator.
Sir, I have a request,
Yeah,
by
Dr.
the end of the sessions, if you can, though we are understanding this, but I still feel some gap. So by the end of the session, if you can refer to us some of the good books or some of the good research articles which we can read to further enhance our knowledge on this particular topic, that would be of great help, sir.
No problem, no problem, no problem. I'll be sharing. I'll be sharing. The best book is Baltagi also.
Okay, sir. Thank you, sir.
Right. So gap in the sense that gap in which sense? Hello. Yeah, ma'am. Dr. Salu. I think you are.
Sorry, sir. Pardon, sir.
Gap in this which sense you are saying gap means what here?
I mean, in my own understanding, maybe I need to read to a book.
So it's simply, of course. So you want like a very elaborative way, right? You think like this, right?
Yes, sir. Yes.
Of course.
Yes, sir. Yes.
So PPT is nothing but PPT is summarized version of the thing, right? So of course,
Yes, sir. Yes, sir. Absolutely,
in
sir.
elaborative way we can go further, and I'll be sharing. Don't
So
worry.
basically, when we write a research paper in the interpretation part or in the writing of the thesis, we, sometimes need to have a very elaborative view of the things.
Of
So
course,
that reading helps us.
yes, I can understand. I can understand. One request, if you permit, then I'll be saying that I want to just resume the session, though there is 1 hour break, but I want to resume from 12:30 so that by 2:30 I can wind up, because there is my personal request. So if you permit, then we can start from 12:30. Will it be fine? Yeah.
Yes, sir. Absolutely fine.
Yes, sir.
Okay. So we can take break only of half hours so that we can be free before half an hour. So that will be also benefit, right? So at 12:50 we'll be coming, and then we'll be starting from 12:30, and hope so we'll be finishing by 2:30. Of course, it will be finished, right? So
Yes.
let's take half an hour break. Dear participants, dear organizer.
Okay, sir. Okay, sir. So I have one announcement for the participants. So sir have given a half an hour break. So we shall be just now sharing the feedback forms. So it will hardly take 5 minutes for you. So I will be sharing the link for the feedback forms here on the this WebEx in the message box, as well as I'll be sharing it on the WhatsApp group, as well as we'll be sharing the link on your mail IDs. So you can access it from anywhere, whichever you find it comfortable, and just respond to that sheet. Okay, it will take hardly 5 minutes, and your test will be scheduled from 3 to 3:30. Okay, so I'll just sharing the link now.
Sir, how many questions will be there?
There will be 20 questions. I think it will take 10-15 minutes at max.
Oh, okay, sir. Okay, sir.
Okay.